continuity equation and conservation of probability or the probability current density. The wave function psi can be represented as probability of finding the particle at a particular point r in space at a particular time, or this probability density p can be written as psi square. So the conservation of probability says that is the probability of finding the particle at some bounded region of space decreases as the time goes, and then the probability of finding the particle outside this region must increases by the same amount. So this is called the conservation of probability, and we can prove this conservation of probability along with the probability current density using equation dou p by dou t plus del dot j is equal to 0. So this equation is called the continuity equation because this equation has the same form as in the case of conservation of matter in electrodynamics, in hydrodynamics, and also the conservation of charge in electrodynamics. Hence is called the continuity equation. So this equation can be proved with the help of Schrodinger's equation. So from the Schrodinger's equation is the theory. From the Schrodinger's equation we know that I h cut dou psi by dou t is equal to minus h cut square by 2m into del square plus v into psi. This is simple Schrodinger equation. So we are taking the complex conjugate of this equation, that is I will be replaced by minus I and psi will be replaced by psi star. So then the equation becomes minus IH cut dou psi star by dou t is equal to minus h cut square by 2m del square plus v into psi star. This is the complex conjugate of this equation. So we are considering these two equations, and this is considered as the equation 1 and this can be considered as the equation 2. So these are the two equations we are getting from Schrodinger's basic equations. Then from the first equation we are just multiplying the first equation with the psi star from the left. We are multiplying equation 1 with the psi star. Equation 1 with psi star from left, and equation 2 with psi from left. So equation 1 with psi star and equation 2 with the psi from the left side. Then the equation 1 becomes IH cut psi star dou psi by dou t is equal to minus h cut square by 2m into psi star del square psi plus v into psi star psi. This will becomes. Similarly for the second equation also, minus IH cut into psi dou psi star by dou t is equal to minus h cut square by 2m into this is psi del square psi star plus v psi star. So these are the two equations. These are the two equations. We are giving this equation as 3, this as fourth equation, 3 and 4. Then next we are subtracting 3 minus 3 from 4. That is 3 and 4 we are subtracting. Then we get equation 3 minus equation 4. What we get? This is equation 3, this is equation 4. Then we get IH cut psi star dou psi by dou t minus dou t plus minus psi dou psi star by dou t is equal to minus h cut square by 2m psi star del square psi minus psi del square psi star. The potential energy component will cancel each other. This is the equation 3 minus 4 we get. Equation 3 minus equation 4 we get. So here also we can consider this IH cut to this right hand side. Then the equation will be psi star dou psi by dou t plus psi dou psi star by dou t is equal to minus h cut square divided by 2m divided by IH cut. So this I will goes to the upper numerator, then it will give plus I h cut square and h cut will cancel. IH cut by 2m into psi star del square psi minus psi del square psi star. This is the equation. This equation psi star dou psi by dou t. This is the equation we get. Or this equation we can written as psi star dou psi by dou t plus psi dou psi by dou t. This is dou by dou t of psi star psi. We can written this equation as, this equation can be written as psi dou by dou t of psi star psi. This is the equation, and this will give IH cut by 2m into, this equation is psi star del square psi minus psi del square psi star. Equation. So we can consider this quantity. So we are defining a vector, that is j. J is a function of position and time. This can be written as IH cut by 2m into psi del psi star minus psi star del psi. This quantity. So the vector j can be written as IH cut by 2m into psi del psi star minus psi star del psi. So we can replace this equation with this j vector. Then it will become dou by dou t of psi star psi is equal to dou by dou t of psi star psi equal to minus, this can be written as, this is del square psi. This can be written as IH cut by 2m into del dot psi star del psi minus psi del psi. So this IH cut by 2m into del dot psi star del psi minus psi del psi. So this dot will become here, and this quantity is j. So this will be minus del dot j. Or it can be written as dou by dou t psi star psi plus del dot j is equal to 0. This is the form of the equation, similar to the equation of continuity in hydrodynamics and electrodynamics, the charge conservation in electrodynamics. This is the equation. So here the term, the vector j, it is considered as the probability density. This is called the probability density. Probability density. Probability density, and which is the flow of probability across the unit area in unit time. This can be considered as the probability density. So we can just rearrange this equation again, that is, we are integrating this over a volume, then we will get dou by dou t over a volume psi star psi d2 is equal to minus integral, volume integral del dot j d2. We are integrating this over a volume. Then we get this. Also we can write this equation as this is a volume integral. Versus law, we can convert it into surface integral. That is, it will be can be written as it's equal to, that is minus closed surface integral j dot ds. It can be written as j dot ds. Anyway, that is, the volume integral is changed to the surface integral with the help of Gauss's theorem. So anyway, this equation shows that this is the conservation of probability, because this is equivalent to probability density. This can be written as psi star psi d2 is the probability density, because when we are considering the probability as, that is, we know that the dp by dt where p is the probability, can be written as d by dt of volume integral psi star psi d2 is the volume integral, or it can be written as volume integral d psi star by dt into psi plus psi star d psi by dt into d2 can be written as. So this volume integral, it can be written as dp by dt. So in this equation dou t by this first term, this will give p, that is dou p by dou t. Dou p by dou t, where p is the probability. According to this equation, p is the probability. Dou p by dt is equal to, this can be represented as dou p by dou t plus it, that is dou p by dou t plus dou p by dou t plus del dot j is equal to 0. That is dou p by dou t plus del dot j is equal to 0. This is the equation of continuity. Anyway, the conservation law states that the conservation of probability says that is, the probability, if the probability in some region increases with the time, then the probability of finding it outside this region becomes, or outside of this region decreases by the same amount. That is, the total probability will be conserved, will remain constant. So this is called the quantum mechanical probability conservation equation. Quantum mechanical probability conservation equation.